Example 5. We want to find the average value of this function over the interval from 0 to 4 using 4 subintervals in the midpoint rule. Okay, we can definitely do this one. So obviously from 0 to 4, if we're going to do 4 subintervals, then the change in x is going to equal 1, because 4 divided by 4, or 4 equal parts, will be 1. Okay, so at 1, remember for the midpoint we're going to go up. Sorry, I'm thinking about one of the other ones right now, but remember at the midpoint we have to go up at the midpoints. So I'm going to go up at 1/2 until I hit the graph, and then draw my first rectangle. Go up at 1.5, so I want to do the midpoint of every interval, and then go up and draw my rectangle. At 2.5, I'm going to go up, and then I'm going to draw my rectangle. At 3.5, I'll go up until I hit the graph and draw my rectangle. So there's 4 equal rectangles with each of the bases being 1. And so the x values that we're going to look at are 0.5, 1.5, 2.5, and 3.5. And so remember, which each one of those, what we're going to do is just plug them back into our equation. I guess these should be t values, not x values, but y'all get the idea. So f of 0.5, figure out what that's going to be. F of 1.5, and that'll be our height there. F of 2.5, and f of 3.5. Okay, so I went in there and found those intervals for us, or the values for us. And then to find then the average value over that interval from 0 to 4. First of all, we want to sum all these up and multiply them by their area. Remember, it's going to be f of 0.5 times the change in x, which is 1, plus f of 1.5 times the change of x, plus f of 2.5 times the change in x, and then plus f of 3.5 times the change in x. When I do all that, it sums up to exactly 2.5. Now the problem though wants us to find the average value. So the average value would just be taking this 2.5, which is over all of it, and divide it into those 4 equal parts. So the final answer then is 0.625. Okay, let's go on to the last problem. In the last problem, we're inscribing a regular 6-sided polygon inside of a circle of radius 1 and computing the area of the polygon. Okay, so 6-sided. Let's see if I can do this. 1, 2, 3, 4, 5, 6. Okay, not too bad. I could definitely do worse, but then it's going to be inside of a circle where all the vertices are hitting the circle. Okay, so pretty much since the radius is 1, then what we can say is from all the spokes going throughout the circle, they have a radius of 1. So 1 there, 1 there, 1, 1, 1. Okay, so if we take out one of these triangles, and let's just focus on this real quick. We have a triangle right here where we know that that side and that side are both 1. And we can kind of split the triangle into 2 equal pieces. Okay, and so now to figure out what the length of this base is, basically what I did is I just pulled out, let's say, example, this triangle right here. Okay, I know for a fact that the 2 sides over here are 1 and 1. Let's find out the length of this base right here. Okay, well, to answer that question, let's look at the interior. If I have a full circle and I go all the way around a full circle, remember I've gone 360 degrees. Well, specifically with the 6-sided polygon, then we need to divide that to 6 equal pieces. So if you divide 360 by 6, that means that this angle right here has to be 360 divided by 6 is 60 degrees. Okay, well, if all 3 angles of a triangle are supposed to add up to 180, then that means that that angle right there has to be 60 and that has to be 60, because they're opposite sides that have the exact same length. So these 2 definitely are the same, and the only way that those can be the same is that they have to be both 60 apiece. So this is, in other words, an equilateral triangle, and that whole base is a 1, or half of the base would be then 0.5. Okay, so now what the question asks us is to find the area specifically of, I think it's the circle. Okay, well, we're going to find the area of the polygon to estimate the area of the circle. So the area of the polygon is made up of a bunch of triangles, and the area of a triangle is going to be 1/2 base times height. So the area is 1/2 times the base. Now how are we going to get the height? Okay, Well, the height, that's where I divide it into 2 equal pieces. We can just use it if we want to. We can just use Pythagorean's theorem where I know half of that one's 5 is 0.5. This is h and this is 1. So 1 squared is equal to h squared plus 0.5 squared. For h, by solving this all out, we'll get h to be the square root of, looks like 3/4, which would be the square root of 3 over 2. So that's the height. So overall, then the area is the square root of 3 over 4. And that's the area for one triangle. So then to find the area of the polygon, all that whole shape in there, the area of the polygon, we're obviously going to say, since there's 6 triangles in there, we're going to go 6 times the square root of 3 over 4, which is 3 square roots of 3 over 2. And if we want to estimate this, let's get an estimate value. That roughly comes out to be about 2.6. Okay, now what if we wanted to find the area of the circle, just to kind of play what ifs? Okay, so the area of the circle, remember that's just pi r squared, and r is 1, so they tell us the radius is 1, so then technically it's supposed to be pi, which is 3.14. So if we use a six-sided polygon to estimate the area, it's telling us that the area should be 2.6. In reality, it should be 3.14. And that kind of makes sense, but look at all that area outside of these triangles that we're missing up on. Just these gaps right here. But what the whole goal with this problem, and when y'all get to your homework, you're eventually going to do, I believe this is number 21 in the homework, what you're going to see is that the more sides that I can create of a polygon, like a square would definitely give us tons of blank space in there, and the square would not be a good estimate of the circle. But the more I create the sides and I up the sides from like 4 to 6 to 8 to 16, the more I up the sides of this polygon that's going to go inside of it, what you're going to see is that this number right here for the polygon is going to get much and much closer to that 3.14.